Welcome to MS 100 lessons, and in this lesson I will be doing a past paper on graphical analysis for Newton's second law. So the question says, learners investigate the relationship between the mass of an object and the acceleration it experiences when a constant force is applied on the object. They use their results to draw the graph below, right? So as you can see from that experiment, they are investigating the relationship between the mass of the object, right, and the acceleration of the object. So now, from our knowledge, we know that the acceleration is inversely proportional to the mass of the object, right? And if we plot a graph of mass or the graph of acceleration versus mass, we get a curve like that, right? But for us, in order to evaluate our graph analysis, one of the variables must be an inverse, right? So we can make the acceleration an inverse, or we can make the mass an inverse. Then we can obtain a straight line graph. So in this case, we have 1 over mass, 1 over acceleration versus the mass of the object in kg. So in this case, the acceleration was an inverse. So that is why we obtained a straight line from this graph, okay? So we can perform our graphical analysis using the steps that we have learned in the previous videos. So from this graph, we can see that whatever is not appearing on this sketch can be calculated using the gradient, right? So we have mass on the x-axis, and we have acceleration as an inverse on the y-axis, right? So the net force is not appearing. It means the net force, we can obtain it from the gradient of the graph, okay? So let us perform our graphical analysis for this one first. So for step number 1 in our graphical analysis, we can see that that is a straight line, okay? So y is equal to mx plus c, right? And then step number 2, we can just substitute whatever variables we have on the y. We have 1 over a, and that m is m of the gradient, okay? And then x, we have the mass of the object, and the y-intercept is 0, okay? And then the equation that we obtain in step number 2 is 1 over a is equal to the gradient multiplied by the mass of the object, right? And then step number 3, we have to manipulate the original formula, which is F net is equal to MA, in such a way that it looks like the formula in step number 2, right? So if we want to make 1 over a the subject of the formula, we can divide by a both sides, which is the acceleration, and we have F net over a is equal to the mass of the object, right? But we want 1 over a to remain the subject of the formula, so we can multiply by 1 over F net both sides. So that would cancel that, and we have 1 over a being equal to mass of the object multiplied by 1 over F net, right? But as you can see in equation number 2, or in step number 2, we have mass at the end, right? So we write this equation in such a way that we have mass at the end, right? So step number 3, then now we can compare, step number 4, we can compare the equation obtained in step number 2, which is 1 over a equal to the gradient multiplied by mass, and compared to what we have obtained in step number 3, 1 over a, 1 over f net multiplied by the mass, okay? So we can see that by comparison, we have 1 over a, we have the mass, and now we have our gradient. And our gradient, we can see that that is equal to 1 over the net force. Okay, so for us to obtain that net force, we have to calculate our gradient and substitute our gradient there. So what is our gradient in this situation? Our gradient would be the change in y. Okay, that would be change in y over change in x, right? But in the y axis we have 1 over a, so that would be change in 1 over a over change in mass in the x-axis. Okay, so we choose 2 points to calculate the gradient. Okay, so we can choose the first point to be the one at the origin, which is 0 and 0, and we can choose the second point to be this one, which is 0.5 to 1, right? So we have 0 to 0 and 0.5 to 1. Okay, so let us calculate the gradient, which is change in y over change in x. So that would be 1 minus the y, that is 1 minus 0, okay, over 0.5 minus 0. Okay, and that would give us a gradient to be 2. So the gradient is 2, and now we want to obtain our net force, and we do know that the gradient is equal to 1 over net force, right? So the gradient is equal to 1 over net force according to our graphical analysis. The gradient is 2, and now we can obtain our net force, right? So the net force, if we cross multiply, that would be 2 times F net, right? And that would be 1 times 1, which is 1, divided by 2, divided by 2. Then we now have our net force being equal to 0.5 newtons. So that is how we obtain our net force using graphical analysis. So we haven't answered any questions yet, but we were just doing our graphical analysis for this graph, right? So let us look at the questions now. We have 4.1, state Newton's second law of motion in words, right? So for 4.1, we'd say when a net force is applied, okay, that is Newton's second law in words. When a net force is applied on an object, so the object will accelerate. The object will accelerate in the direction of the net force. Okay, and now we talk about the magnitudes. The acceleration is directly proportional to the net force and inversely proportional to the mass of the object. Okay, so the key terms there is that when a net force is applied, right, the object will accelerate in the direction of that net force. Okay, the acceleration is directly proportional to the net force and inversely proportional to the mass of the object. All right, so that was 4.1. And 4.2, calculate the gradient of the graph, right? So the gradient, we have calculated the gradient as 2. So this is 4.2, right? So this part here is 4.2. This is the gradient, right? And then hence determine the net force. So the net force on the object, this is the calculation that we have made through our graphical analysis. So the net force, that is 4.3. Okay, and then write down the conclusion for the experiment. So they were investigating the relationship between the mass of the object and the acceleration, right? And as you can see, we have made one of the variables to be an inverse, right? So we can see that the acceleration is inversely proportional to the mass of the object. So 4.4, the acceleration is inversely proportional to the mass of the object. Acceleration is inversely proportional to the mass of the object. All right, so this is one of the examples that we can illustrate using our graphical analysis.